A cylinder contains 1 kg of a certain fluid at an initial pressure of 20 bar. The fluid is allowed to expand reversibly behind a piston according to the law PV to the power 2 equal to constant until the volume is doubled. You can see here the fluid is allowed to expand reversibly behind a piston according to this law until the volume is doubled here. The fluid is then cooled reversibly at constant pressure until the piston regains its original position. Heat is then supplied reversibly with the piston firmly locked in position until the pressure rises to the original volume of 20 bar. Calculate the net work done by the fluid for an initial volume of 0.05 meter cube. So in this problem, data what he has given means mass he has given 1 kg. Initial pressure of the gas it was 20 bar. So it is following the law. It is polytropic process PV to the power n equal to constant. Here n that is polytropic constant he has given it as 2 PV to the power 2 equals to constant, where V1 initial volume he has given 0.05 meter cube, and the piston is fluid is allowed to expand reversibly until the volume is doubled. That means V2 is equals to 2V1 because this volume until the volume is doubled. So in the condition he has given in the problem. So V2 volume at state 2, I will give it as 2V1. That means here the volume initial volume is 0.05 meter cube. The fluid is allowed to expand until its volume gets doubled. That means V2 is equals to 2V1. 2 into 0.05 equals it will be 0.1 meter cube. Then next he has given heat is then supplied reversibly with the piston firmly locked in the position until the pressure rises to the original value. So here the piston regains its original value. You can see here the fluid is then cooled reversibly at a constant pressure. The fluid is then cooled pressure at constant pressure means horizontal line. The fluid is then cooled reversibly here at constant pressure until the piston regains its original position. So this is my original position here. That means here we are having three processes. Process 1 is to 2, process 2 is to 3, and process 3 is to 1. You can see here process 1 is to 2, it is a polytropic process. Process 2 is to 3, it is a constant pressure process, and process 3 is to 1, it is the constant volume process. Now we will solve the problem. So he has asked us to calculate the net work done. So the work done during this process I should calculate first, then work done during this process, then work done during this process. Then I have to add all the works. Then that is my net work done by the fluid. See here now. Now process 1 is to 2 is the polytropic process. Already I have told you. So equation is P1 V1 to the power n equals to P2 V2 to the power n. So let me calculate first P2. So P2 how I will calculate P1 V1 to the power n divided by V2 to the power n. So P1 I have taken outside V1 by V2 to the power n. So 20. So V1 by V2 if we will simplify it, this is 1 divided by 2 to the power square. So if I will simplify this, P2 will be equals to 5 bar. So already we have calculated V2 value. So now work done. This is the formula to calculate the work done during polytropic process. P1 V1 minus P2 V2 divided by n minus 1. So P1 it is given in bar. So I will convert this bar in kilonewton per meter square. So this will be 20 into 10 to the power 2 kilonewton per meter square into volume V1 is 0.05 meter cube minus P2. P2 is 5 bar. Again I will convert this bar into kilonewton per meter square. So this is 5 into 10 to the power 2 into 0.1 meter cube volume at state 2 here divided by n minus 1. So n is 2 minus 1. So if I will calculate this work done during polytropic process, it is 50 kilojoules. Now coming to the next process, that is process 2 is to 3 is the constant pressure process. So for constant pressure process, how we'll calculate work done? Work done W is equal to P3 V3 minus P2 V2. So already it is a constant pressure process. So pressure at point 3 and pressure at point 2 will be same. P3 is equal to P2, constant pressure process. So I will write here P2. P3 I will replace it by P2 only. P2 V3 minus P2 V2. So P2 I have taken common. So it is V3 minus V2. So the pressure at point 2 is 5 bar. So I will convert here in again in kilonewton per meter square. 5 into 10 to the power 2 into V3. So volume, it is volume at state 1 and volume at state 3. Both are same because it is a constant volume process. So V3 is nothing but V1 only, 0.05 minus 0.1. So this is work done. W doing constant pressure process. It will be minus 25 kilojoules here. Now last process. Process 3:1 is the constant volume process. So already I have told you for constant volume process, work done W will be equal to 0. So now net work done during the entire process. So this work, that is 50 kilojoules plus, that is minus 25 plus 0. So net work, NW means net work done during the entire process. It is nothing but 25 kilojoules.